Okay, so we're going to break the transformations down into 2 days. Maybe more, just depends how long this takes, but the goal is 2 days. 1.6, day 1, we're going to talk about translations and reflections, and then we'll do stretches and shrinks tomorrow, day 2. So first of all, we have a transformation function formula. I'll write that down at the very top. So we have a formula, and this formula is going to look like, let's see, I'm going to try to color some stuff in here too. A, we'll have F, parenthesis, that doesn't look like parenthesis. For that A, I might have to do plus or minus in front of it also. I'm going to change that color to plus or minus. I'm going to run out of colors totally. Maybe not. Okay, the crazy long, just way too many letters formula. Yeah? This represents a function with all the possible transformations you could ever have on a function. Now, I'm talking about a function because we're talking about any particular parent function that we learned in section 1.5. Like we learned, or we went over square roots, we went over squared, we went over cubes, we went over the reciprocal function, that 1 over x. All of that stuff we can use as the function. And in this formula, f of x is the parent function. So if f of x was an x squared, then wherever you see the black in this original function would be that x squared. The x would be the x, and then all those parentheses, the f, that would be the squared part. Or if it was an absolute value, the black part would be the absolute value bars, where the x would still be an x. And then all these things being done to it have different transformations. Down below, I've got horizontal transformations labeled, and I've got, even further down below, vertical transformations. So we want to look at horizontal transformations and vertical transformations separate. And then you'll see in these functions, we've got x minus h, x plus h. We've got f of negative x. We've got b times x and 2 different versions of b times x. So we've got all these different possible transformations. And then if you look back at my original little formula function here, we have the b and the h in this formula. So anything that's in the b spot or the h spot, those are all horizontal transformations. And I'm sure I have it written in here, but transformations for horizontal, they are always inside of the function with the x. It might be in parentheses or understood parentheses. Like absolute value bars would be parentheses. A square root symbol would be a parenthesis, even though it doesn't look like a parenthesis. So anything inside of whatever particular kind of function it is going to be horizontal transformation. And then the second part of horizontal transformations that you need to know is that any horizontal transformation is opposite of the operation in the function. So for the first example, x minus 9 squared, that has a horizontal transformation because it's inside of the squared. But because it says subtract 9, we actually do the opposite, which is add 9 when we go to use that transformation. So since it's horizontal, my example here, since it is horizontal, we're talking left or right, right? Horizontal would go left or right. It would not go up or down. And because it says -9 inside of the transformation, I'm sorry, inside of the function, the transformation would be the opposite of -9, which is +9, which goes to the right. So it's like common sense. I would think it goes left, but horizontal is always the opposite of that. The very top? Yep. It's like plus or minus a, and then f of is the function, plus or minus b, parenthesis, x, plus or minus h, close parenthesis, plus minus k. Okay, so going back down here, so I have a couple more, or I have another example there. It's basically the same thing. This one here says that f of x plus 2, that is a horizontal transformation, but you do not see parentheses for it because for this one, the parent function is parent function is 5 to the x. Here it's 5 to the x plus 2. There's understood parentheses around this exponent because x plus 2 is the entire exponent. So you're not going to see the parentheses, so you have to know that they're there. So that this would be a horizontal. And if it says plus 2, when I use it, I'm not going to use a plus 2. What am I going to use? What's the opposite of plus 2? Minus 2. Okay, and then right here it actually summarizes what you have to do, all the things I'm going to talk about while I'm doing these notes. And a lot of you should remember this stuff, so I'm trying to not spend too much time on this, where I can spend time with you individually if you're struggling. All the vertical transformations are like total common sense. First of all, vertical transformations are on the outside of the function. So you can see this example right here that says p of x equals absolute value of x minus 7. Minus 7 is on the outside of the function and it's not in the absolute value. And because vertical, they're kind of common sense, they use the exact same operation from the function. If I have this absolute value of x minus 7, we just literally subtract 7. But it's vertical, so this would make it go down when we subtract, because vertical would be up or down. So subtract 7 would make it go down. Here, where it says it there. Okay, one more thing I just want to kind of specify is the reflections. So the reflections, we're going to do that today as well. Reflections, here's an example of a vertical reflection. This is a vertical reflection. And then the horizontal reflection would be up here, f of negative x. So one has the negative inside of the function, the other one's on the outside of the function. So here is an xy axis. Here's another xy axis. In this first xy axis, we're going to do a vertical reflection. In this one, we're going to do a horizontal reflection. Okay. I want you to imagine if I vertically reflected the pink heart, scroll up. You need to go this way? Is that what you mean? Oh, okay. Sorry. You just need to see what I was talking about. I mean, they're all here. They're not going anywhere. What I really want you to understand is visually here what the reflections look like. So I'm pretty sure if you guys thought about this, we're going to vertically reflect this heart. Where's the heart going to go? Right now it's in the first quadrant. Where's it going to go? It's going to go down to that fourth quadrant. It's going to flip down. So a vertical reflection is going to flip up and down. And then it would be like an upside down heart here. Not drawn perfectly, but approximately would look like that. Okay? What axis did I just reflect in? Amol? Yeah. So when we do a vertical reflection, we say we reflect in the x-axis. So that contradicts what you think. As a vertical, you're typically thinking y, but it literally is going over the x-axis. So you say the words x-axis with it. So if you forget which one is which, you can always draw a picture. So for the horizontal, if I reflect horizontally, that's going to go left, right. That's how we normally think about x's, going left, right. But we're reflecting in the y-axis. So a horizontal reflection, reflect in the y-axis. Again, it kind of contradicts what you would normally think, but it's because of the direction it's reflecting and which axis it's reflecting over that you label it that way. Okay, in these boxes, I have what you say about it and then like what you do to find values, but we're just going to really just go over that with examples. Okay, so the first thing that we're going to do is we're going to look at our parent function. So question A, parent function, you look x squared minus 3. The parent function is x squared. So my y column is an x squared. I'm going to start with a parent function points that we did in section 1.5. Now, I always start with these because those points will give me the middle of the parabola. If you just start with random points, it's possible you have to find a lot more points to find the middle of the parabola, the vertex. I start with these so I will get the middle of the parabola. And then you should have plotted these a million times last year. I can't guarantee you did, but you should have graphed a lot of these. So like for me, I have them memorized where they are every single time. I don't have to count the points. They're just always in the same spot. We are going to label any transformations. So we look at the equation, and the equation has a -3. That's different than the parent function. So we say, is this on the outside or the inside of the function of the x squared? Katie, do you know? Wow. It is on the outside. It is not part of the x squared. So that means it's going to be vertical. If it's vertical, it's like up or down, and it's exactly what you would think it would be. This says -3. What do you guys think it is? Up or down? When it's vertical, it's just like complete common sense. It keeps the same sign. Yeah, it's going to be down. We write translate down 3 units. We write translate down 3 units. Then we have 2 ways to graph it. We literally can take the graph and move every single point down 3 units. That's one option. That is the easier option here. But eventually they get challenging, and we need to know how to do the table. So I'm going to do both for each of these. You do not have to do the table if you literally can look at the graph and be like, let me just take each point I had and move it down 3 units. If you do it that way, you don't have to do the table, okay? But I'm going to do the table because eventually we'll probably need them. If I'm translating down 3 units, that's a y value change. So I go to my y column and I subtract 3 from all of the y's. And what's nice about the parabola is that it is symmetric. So once I do like the first 4 values, the rest of them repeat. So I don't really have to do that much work. And either way that you did it, you should have the same picture as me. There we go. Okay, on Thursday, Friday, you were supposed to watch that video about what's called interval notation. And do a graphing assignment and just write your domain and range in interval notation. So I'm going to go over that now as well. So first of all, I'm going to think about domain and range in set notation, the way we were doing it. So I'm going to look at this pink parabola and I'm going to say, what is the domain? How far to the left does it go? How far to the right? Who can tell me the domain in just like regular words? Trinity. It's all real numbers. Okay, that's set notation. That's what we were doing. Now we're going to write that in interval notation. To show all real numbers, we have to go from negative infinity to positive infinity. So you are starting all the way to the left at negative infinity. You end at positive infinity. We use parentheses because infinity is not a real number and it will never equal infinity. It goes on forever. So we use parentheses to demonstrate that it does not equal infinity. The range, just in set notation, Lindsay, can you tell me the range for this one? Right. Yeah, so what are the y's doing? How far down do we go for the y's? Negative 3, and then it goes where from negative 3? Up forever, right? So like in set notation, the way we were doing, we would say y is greater than or equal to negative 3. That's what we were doing. That's set notation. But now we're going to do interval notation. For interval notation, we say, well, it could equal negative 3, and then it goes all the way to positive infinity. But because it could equal negative 3, I write that as a bracket. So if it can equal it, it gets a bracket. If it's not equal to, then we get a parenthesis. So we are just showing the starting number and the ending number for interval notation, rather than a greater than equal to symbol. And then we're done with question A. Question B. Yep, sorry. I like to go fast. Question B is another parabola. Oh yeah, I'm sorry, what? Set notation, you're using like the variable and you're using like greater than equal to. Interval notation is saying start at this number, end at this number. You'll see it as we do more and more examples. It's just a different way of writing stuff. Just like it's going to measure the same thing. Centimeters and inches, they measure the same thing, but they're different. When you get to higher level math, you'll use interval notation more often, but sometimes you can't write stuff in interval notation, so you have to know both. All right, question B is another parabola. I'm using the exact same parent function points that I used right above. This time our transformation is +5 and it's on the inside of the squared. If it's on the inside, Charlie, if it's on the inside, can you tell me anything about it?
The inside
of the squared, it's x + 5, but it's on the inside of that squared. Do you know if that's going to be vertical or horizontal?
Oh. Vertical? No.
Okay, question A was on the outside, and we did down.
It's horizontal.
So it's horizontal because it's on the inside. Horizontal's on the inside. How about horizontal? Let's do this. I'm literally making this up right now. Horizontal inside says hi. Hee hee. Okay. I just made that up. So there you go. Horizontal inside. Hi. No. Okay. So horizontal is also opposite of everything that we would think it would be. So when you see a +5 there, horizontal is going to be opposite. Ho. Hi ho. Hi ho. Hi Hi-ho. So if I see a +5 there, Chad, CJ, my bad. If I see a +5 there, what should I actually be doing? I should go to the left 5, yes. And thank you for using all that vocabulary. Translate to the left 5 units. So on your graph, you can take all those points and just move them 5 units to the left. That's one way of doing this. Or in the table, I'm going to go to the X side and -5 to all my X's. And so our domain, normally we would say all real numbers because it goes all the way to the left and all the way to the right, but we're going to write in interval notation that says we go from -infinity to the left to +infinity to the right. It's our starting and our ending spot. Range, we're going to go from down to up. Zoe, how far down does this range go? Did you say 0, hon? Yes. So I'm going to say it starts at 0, and I'm going to write that with a bracket because it does have a point there. And then it's going to go all the way up to infinity. And infinity always gets a parenthesis. The next one is x squared again, so I'm quickly just drawing my parent function and writing down the points since we just did that one twice. Okay, this one has multiple transformations. I like to go left to right with my equation. I like to go left to right. So the very first thing that I come to is a negative sign. That negative sign, is that inside of the squared or outside of the squared?
Outside.
It is on the outside. It does not have the squared on it. So that is vertical. And that +1 is also vertical. The -2 is on the inside, so that one's horizontal. So I'm going to start with the negative. That is a reflection. And it will always say reflect in the, and then we have to say the correct axis. So if this is a vertical reflection, we're taking our heart and we're going up, down, up, down. What axis is this reflecting in?
Y.
Which axis, Brian? Is it
Y.
this one?
X.
That's the x-axis. So that's the one it's reflecting over. So it has a reflection in the x-axis. Then that -2, that -2, it's on the inside. Liam. +2. So what direction? We're going to translate. What'd you say? To the right 2. Yeah. Translate 2 units right. And now I'm not going to rewrite the word translate because the next one is also translating. So, and we have 1 unit where? No, down, it's not correct. So if it's vertical, you use the sign, that plus sign. Like you'll use the sign that is the same. Katie, Sailor? Okay, Katie.
It's going up.
It's going up. Yeah, 1 unit up. So you can try to do this by hand. You can move it, or you can reflect it down and then translate it 2 units right and 1 unit up. You can do that by hand. We can also use our table. If you are using the table, there are 2 vertical transformations. The order in which you do the vertical transformations matters. The order is going to be PEMDAS, which is order of operations. So I have multiply by -1, and I also have add 1. Out of multiply by -1 or add 1, what should come first? Multiply. Always multiply before adding. So I'm going to do that to the y values. First, I'm going to change all of their signs to negative. Then I'm going to add 1 to each of those. On the x side, we've got translate 2 units right, which makes me add 2. It's the opposite of what's in the equation. And I do that to all the x values because it's horizontal. And then the ones that I graph are the very final x, y's that I translated. Those are the ordered pairs that I graph.
We don't gotta do that table.
If you can just do it by hand, you don't have to do the table. You will get to a place where you will have to do the table, which is why I'm doing it for every single one right now. Okay. So -1, -8, 0, -3, 1, 0, 2, 1. And eventually, since it is a parabola, it has symmetry. So once you get some of these points down, the rest of them are pretty easy. Now, as you're doing this yourself, you're going to have an answer key that's posted where you'll be able to look at it. If you're getting them wrong and you're not using a table, may I suggest we start using the table if you're getting them wrong when you're not using the table. All right, the domain. So we're talking about interval notation. Domain's going to be all the way to the left, all the way to the right. All parabolas have the domain of -infinity to +infinity. The range. So we're going to go, how far down does this guy go? Zane. How far down does this go? Yeah, it goes all the way to -infinity. So I'm going to write that first because that's the down. And then it's going to go all the way up and it's going to stop. AJ, what number does it stop at going up? 1. And it can equal 1, so I make it a bracket. Where students will make a mistake is they will put the 1 first and then the -infinity because they're thinking about just going down. But we put this in order from least to greatest. So we need to put the -infinity first. Okay, this next one's important example here. Important example here. First of all, it's a square root of x. In 1.5, we talked about the best numbers to use for square root of x for the parent function. And it's 0, 0, 1, 1, 4, 2, 9, 3. Because we take the numbers that we can square root, and that's our parent function. So if you guys have this in front of you right now, if you have the equation in front of you right now, I'm going to go back to my formula that I put on the first page. If you guys have this equation in front of you, square root -x minus 3. I'm going to go back to this other formula because I want to show you something. So inside of the function in this formula, there's a set of parentheses inside of the function parenthesis. And this plus minus is on the outside of a transformation. if you have a plus minus or a number, which is tomorrow, we won't have any B's today. But if you have a plus, you're only going to have a minus. If it's plus, you won't see it. If we have a minus and it isn't separated by parentheses with a transformation, you have to do an extra step. So if we have this example where we have, it's over here. If we have a minus, a negative sign, and it is not separated out with a parenthesis, we have to use factoring to do that. So I'm going to rewrite this equation. I'm going to factor out the negative. And when I factor out the negative, factoring out the negative is really factoring out a -1. When I factor out that -1, I'm going to divide each of these terms by -1. I'm going to get x plus 3. Oops. Factoring out the -1 will change the signs. So you have to have these two transformations separated from each other. If you don't have them separated, if you use this one and not this one, you're going to get something wrong because these are two different signs. So you got to make sure that you have it factored out when you have a case like this. This is an important one to use when you do your assignment. So for these transformations, if we have a negative sign, that's going to be a reflection. We have to determine which axis it is. So if we have a negative sign and it's under the square root, that's part of the square root. That's part of the function. That's inside the function. So it's going to be horizontal. Horizontal is inside, high. So this is a reflect in the, and if you forget which one it is, you can take your heart and you can reflect it horizontally and say, which axis is that reflecting over? If I have a heart and I reflect it horizontally, which axis would that be? Anybody? The y-axis, right? And then we have translate 3 units. And this is also horizontal because it's on the inside. So we do opposite, hi, ho, it's opposite. So what is opposite of positive 3? Left 3, yeah. So we're going to reflect in the y-axis. We're going to translate 3 units left. You can take your points, reflect, and move it to the left, or we can use the table. I'm going to use the table so you have seen it. Both of these are horizontal, so I have to do multiplication first, and then minus 3. Then I graph the outside x and outside y. So I get -3, 0, -4, 1, and then -12 is off the graph. So reflected in the y-axis, left or right, and then we moved it 3 to the left. So the domain, we go left to right. So Amul, how far to the left does this go? Okay, so what do I call that? Which one? Negative infinity. And then it goes to the right to what number? Okay, so I'm going to write negative infinity to -3. I get a bracket for -3 because there's a dot there. Infinities never have brackets. They always have parentheses. And then the range. How far down does it go? Anybody? How far down? 0, right. So we're going to start at 0, and it can equal 0. And then how far up? There's an arrow. So how far up does it go? There's an arrow, so nothing's stopping it. How far up? Yeah, infinity, infinity. Okay, so this last one here, I'm not gonna take a ton of time for the graph right now. We had one of those on the 1-3 example. I just wanna go over the transformations and write your domain and range real fast. So the transformations for this one, when you talk about horizontal versus vertical, excuse me. And by the way, the parent function would be 1 over x. The horizontal versus vertical transformation, for this one, the horizontal would be the denominator because that's where the x is normally. So this horizontal, and we know that's inside the function, it's opposite. So this would be translate 2 units right. And then this -4 out here would be vertical. 4 units down. And then for the domain and range, I'm going to sketch it, but you guys won't have time to like do all this full out right now. So oops, that's the wrong way. That's to the left. I need to go to the right. This is the one that has the asymptotes. So 4 right, I'm sorry, 2 right, 4 down will make the asymptotes go over there. And then the actual graphs will be in here. Sorry, I'm just like sketching this really fast because I just want to talk about, well, I already talked about the transformations. I want to talk about the domain and range. When you have this one, the domain goes from left to right, but the asymptote is something it skips over. So when we look at the domain, there's actually 2 pieces on the graph. We call them branches. There's 2 pieces. So there's going to be 2 pieces for your domain. There's going to be 2 parentheses for your domain. And inside, between the 2 parentheses, you're going to put a union symbol, which means these go together for one thing. So we're going to start at negative infinity, and it's going to go all the way to the asymptote, which is at 2. It does not equal the asymptote, so we use a parenthesis instead of a bracket. And then it begins at 2 again and goes to positive infinity. It does not equal 2. This is showing that it's everything except for it skips over 2. The range is the same way. We have 2 pieces for the range. So that means the range is going to have 2 pieces. And we're going to start at negative infinity and we're going to end at positive infinity. But what number are we going to skip over? Almost 4. Which 4? It's the -4. And that comes from my asymptotes, which comes from my translations. Normally the asymptotes are at 0, 0. So our transformations are going to move the asymptotes. So that's how you can get your domain and range for that one. It's from the asymptotes. Which is the translations. That's what I tried to write really fast, translations. We won't finish this one. It's absolute value, but I wanted to show you right here. If you have a negative sign and a translation here, you have to factor. So this one I'm going to rewrite as negative absolute value, negative parenthesis, x minus 1 plus 3. So we had to factor out the -1. Before we start that one. This assignment isn't due, I don't remember what due date I put on it, but you're going to have 2 days to do it. In class tomorrow, I'm going to teach the rest of the transformations. You should work on this assignment, even though it's not due tomorrow, because if you don't practice it at all, it's going to be almost like starting from scratch again. Work on this assignment. You'll have 2 days to finish it, but work on it because then you're going to have another assignment tomorrow. By Friday, we will have a quiz on this. On Friday. Have a great day.